Welcome back to another episode of the Physics Friar. In this episode, we will be defining or giving you Newton's first law of motion. So what is Newton's first law of motion? Well, first of all, who is Newton? There he is. He was an old Englishman with long hair, and he was also a genius. All right, so imagine that most of you think about motion in the following manner, in an Aristotelian manner. All right, let's say you have a table and you have some books on the table represented there by that green block. Okay, and I imagine most of you think that in order to get those books moving and keep them moving, you have to push on the stack of the books. If you stop pushing the books, then they stop moving. In other words, in order for an object to move, you have to push on it. You have to apply a force. This is the way that Aristotle thought. Aristotle thought that the books wouldn't move in the absence of a force. If you don't push on them, they stop moving, they don't move. Well, it turns out that Aristotle was exactly wrong. And by exactly wrong, I mean he had it upside down, the wrong way around. It turns out that in the absence of a force, books continue to move. It's only when there is a force that an object changes its state of motion. Galileo said, in the absence of a force, a moving object will continue moving. In other words, in the absence of a force, if those books are moving, they would keep on moving. You don't have to push on the books to keep them moving. Now, you may be ready to have a big argument with me, so hold on to those objections, and let's go straight to Newton's first law. So Newton's first law starts out as follows. Every object continues in a state of rest or of uniform speed in a straight line, unless it is acted on by a non-zero net force. That's what Newton said. So Newton took what Galileo said and kind of polished it up a little bit. And that is Newton's first law. The key word here is continues. Every object continues to do what it was doing before in the absence of other forces. So let's break this definition down a little bit. Objects at rest are going to tend to stay at rest. They continue to stay at rest. Objects in motion are going to tend to stay in motion. They continue to stay in motion. And that means at a constant speed along a straight line path. So an object in motion is going to want to keep on going like a freight train, just in a straight line at the speed it was going at. Objects continue to do whatever they were doing before. So, in sum, you could say that objects are lazy. Objects have inertia. When you hear the word inertia, you should think lazy. Objects just want to keep on doing whatever they were doing. If they were at rest, they want to stay at rest. If they were moving, they want to keep on moving just the way they were before. That means in a straight line at a constant speed. They don't want to slow down. It's hard to slow down. They don't want to speed up. It's hard to speed up. They don't want to turn. It's hard to turn. They just want to keep on doing what they were doing. They're lazy. So let's go back to those books. All right? You say that you have to keep pushing on the books in order to keep them moving. But you're forgetting about something called friction. So once you stop pushing on the books, you think to yourself, there are no more forces acting on the books. That is not true. In fact, there is a force acting on the books, and that force is friction. So after you stop pushing on the books, friction acts on the books to slow them down. It's as if friction were pushing on the other end of the books to stop the books from moving. If there were no friction and the books are moving, they continue to slide right along the table without stopping. So it's only when there are no forces acting on an object that it continues to do whatever it was doing. In the absence of a force, an object continues to move if it was moving before. In the absence of friction, those books would continue to move as they were before if they were moving before. And that is Newton's first law of motion.